No overcast. Isn't this fun? Okay, well, let's, hold on a second.
Just give us a minute.
Technical difficulties.
Please stand by.
They're here, Dana's here!
Hey!
Hi, Maria!
I'm gonna drop this.
So we have people from Quebec to
Petawawa.
Petawawa to
Collingwood.
Meaford, Barrie, and Winnipeg. The Frosts, I think, are in Winnipeg watching this as well.
Nice.
Yeah, so we're all over. Cool. So let's just begin.
Okay.
Let's begin, and if other people can see, let's just begin. So what we're going to be talking about today is an introduction to binary.
Right over
Yeah,
there.
that way.
This way. No.
That way.
That way. Yes.
Introduction to binary. Oh, I did it again.
Okay.
Okay. So the state of the course. This is our fourth lesson, believe it or not.
Wow.
The first one was the introduction, and it's kind of thrown together. And we did the history of calculation, a more boring episode, even if I do say so myself. But we did learn about the abacus. So you at least watch the first 10 minutes of that one to learn about the abacus. That's really important. You can make one out of little pasta noodles and stuff, kids. It's awesome. We talked about logic, last class.
Logic. You need it.
And the whole point of that class was there are math symbols that we know, like pluses and minuses and divisions and stuff. And equals. And yeah. And we use more in computer science. There are 3 more that we use, mainly. There's actually a lot more that we use, but the main ones are ands, ors, and nots. And we made some of those gates in Minecraft. So we made some of those math symbols in Minecraft. Minecraft! And so we're going to review those today before we start anything. And then now we're going to do binary, because it goes right into circuits, because a circuit off being a 0, and therefore a
on is a 1.
On is a 1, right?
I am learning.
So that's state of the course. And then I'm thinking about doing another class in binary just for the older kids, for the Mackenzies, for the Ainsleys, maybe for the Waverleys, where we're actually converting from base 10, from decimal numbers, from normal numbers to binary. It might be too hard for the younger kids.
You can try it if you want, but you might not.
But we might do another intro one. Yeah. So that's basically it. And then we're going to do some looping, some conditional, some crypto. And the Lester boys, we're still going to do that crypto for you. Okay. So what does that say, Ainsley?
There are 10 types of people in the world. Those that understand Those that understand binary and those that don't.
Yeah, it's a little joke, right? But there's really only 2 types of people in the world. Those that understand binary and those that don't. So 10 is the letter 2, is the number 2. It's a little dad joke. It's the best thing I can come up with. Okay, so we're going to start off with a little bit of review. Name some math operators, Ainsley. Or type them into the comments. Type some math operators that you know into the comments.
We will wait.
No, we won't wait. Just we'll go. It's an ongoing. It's a fluid process.
Okay, we have. Do I need like?
Yeah. Just,
okay. We have addition, subtraction, multiplication, division, equal to, greater than, and less than.
Yeah.
Those are important too. People keep forgetting them.
Yeah. Good. Name some additional operators used in computer science.
If or not.
Yeah, and or not are the 3 major ones that we're going to be using. Okay? And now we're going to practice our powers of 2.
Oh.
So there are some new kids who are with us here. What we're doing is we're just taking a number. We're starting with the number 1, and we're doubling it and doubling it and doubling it. And this is kind of like our multiplication tables, like our times tables. Kind of. But it's just something that we're learning, because we're going to be doing this a lot today. We're going to be using our powers of 2, so hopefully everyone remembers them. So we're going to start off by saying them out loud, and they're right up there.
Besides, if you can see the comments on the screen.
Yeah, it's right up there.
Yeah, it's right up there.
Okay, so 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024.
1024.
1024. Okay, I want to do one more time. 1042.
Yeah. And not true, false, or.
Yeah, that's right, Waverly. And not true, not false, or. And or. Okay, so let's do our powers of 2 again.
Okay, one more time.
Okay, one more time. So we're starting at the top and going from the bottom. And we'll do it a little bit slower this time, because there's little ones. Okay? 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. But really for today, we're going to be focusing on the first 4, 5, 1, 2, 4, 8, 16, 32. So that's what's going on.
Remember those.
Okay. So now we're going to practice our powers of 2 again, but we're just going to have it going from kind of backwards to forwards. Right? So let's do it again. 1, 2, 4, 8, 16. Huh. It's a little funny, huh?
Yeah.
Okay.
It's a little.
So why are we going to learn binary today?
I don't know why.
Well, it's on the slide.
Oh,
And we already had this conversation actually because I knew it would go like this. Okay?
binary works well because circuits have 2 states: on or 1 or true, off or 0 or false.
Yeah.
Now let's review the gates in Minecraft. Yay!
Let's review the gates in Minecraft. So we're going to load up Minecraft here and look at the gates that we learned.
Give us
So-
a second. Give us a second.
Yeah, so the cool thing about the gates is that, so we said we have these operators, we have these symbols, right? Like a plus symbol or a minus symbol. The cool thing, you press play. The cool thing about computers is that we have these ands, ors, and we can create these in circuits.
Oh, it's loading.
Yeah.
But they can't see it. Oh, no, they can.
Yeah, it'll load, yeah.
It's loading.
Yeah,
It's
so we can
loading.
create these in circuits. So we made some circuits in Minecraft, and we're going to show them to you. And it's going to be a lot of fun.
Nerd life!
Nerd life!
Nerd life!
Play selected world. Okay, so
Excuse
I'm
me.
going to show them. You can work from there.
Jeez.
Okay. So go to the first circuit. Okay. So as you can see, it's a circuit, and when you turn the
Oh, sorry. Hold on, I'm
Yeah.
trying to move the mouse over closer to me. Okay. There we
Yeah. and you move the switch, it turns the signal on or off. On. Off. On. Okay. Now here we're adding a little bit of a delay. All it does is just delay the signal a
go.
little bit.
Just a tiny bit.
Just a tiny bit. So there's a little pause, right? Delay. Good. That's that. So now we're coming to our first major gate, which is the OR gate. So the OR gate is one of them is true, or the other one is true, or both of them are true, and that will light up the light. So light up one of them, it lights up. Light up the other one, it lights up. And now the first one, it lights up. And now all 4 of them off, all 2 of them off. Done. That's an OR gate. A NOT gate is
From the side,
change it.
sorry.
Yeah, you can look at sideways. It changes a false to true and a true to false.
So we have a redstone torch and a redstone.
So it's off. The signal going in is off, and the signal going out is on.
And
And then if you switch it, boom, now the light's off. Awesome. And now we'll do the AND gate. The AND gate works kind of like the word AND in English. Well, hi, Monkey Bear.
no, it's a
buddy.
Mocha Bear.
Okay. It works kind of like the word AND in English. So both of them have to be true in order to send true. So try one of them. Hi.
Turns off
It's off.
one.
Still not on.
It doesn't do anything.
Try the other one. That's still not on. Now try both of them.
I have to keep walking back and forth.
Okay. Good. Now it's on.
Beautiful.
Right, now, do you want to walk to and
here?
forward, and just stop right there.
Here? Okay.
Yeah. Now save and quit.
Skip. Save and quit to title.
Yeah, because we're going to use that for the next lesson, the next part. That's actually a binary anyway. It's going to be cool.
Oh.
Quit game, just to save our server. And now we're back here. So,
Ta-da!
does anyone have questions on the review? Hopefully not.
Let's just wait a little bit.
Yeah, we're going to wait a little
Just
bit.
a little.
Okay. But-
Whoa, we're on the next slide. We have to go back to the first one.
Okay, no questions from the Libbies. Okay, so here's a little brain teaser. Now, so we just did this one. Okay, so here's a little brain teaser. Can you make the number 3 by adding a combination of these numbers together? So you only get to use each number once, and you have to add them together. So you can't do like a
8 and 8.
8 and 8 to make it 16. Yeah, so can you make the number 3? All right, by using each number once. How would you do that? Make the number 3.
I would use the number 2 and the number 1.
2 and the number 1. Yeah, because it's easy, right?
Yeah, 2 plus 1 is
2 plus 1 equals 3.
We're allowed to minus.
Okay?
No questions from the
Okay, right?
Yeah.
Maria says it's fun too.
Yay!
Okay. Okay, so now can you make the number 6?
Ooh.
Can you make the number 6? Sorry, we'll put up the numbers here. How can you make the number 6 using these numbers? Only one of these numbers. One of those. Sorry.
Those.
My arm doesn't work. Those numbers. There's a 4, yeah?
Yes, and a 2.
4 and a 2. Oh, 2 and a 4. Okay, yeah.
Yes.
4, 2. Okay, so 4 plus 2 equals 6.
24. If you look at it.
What?
Look, if you look at it from a perspective, it's like 2, 4. 24. You know
Yeah, and if I had wheels, I'd be a bicycle. Okay. So, here's a tougher one. Now, can you make the number 13?
Wait, hold on.
Okay, so
I don't remember this.
I know, because this is new for you. Yeah. So, can you make the number 13? Now, it's an odd number, so you're going to need the number 1, obviously, right? So, you're going to use the number 1. What other numbers would add to...
I figured it out.
Okay. So, what is it?
8, 4, and 1.
Yeah.
Because 8 plus 4 is 12, and plus 1 is 13.
Yeah. 8 plus 4 plus 1 is 13. Cool, eh?
Yeah.
Okay, so pretty easy stuff, but you know what we're doing right there, right? Doing this, you know what we're doing?
That.
Yeah, that.
Is that binary?
The binary, yeah. But now we're just going to learn the math. Okay, so remember place values. Remember
Yes.
learning about...
Let me just...
Let me get comfortable here. Okay, and reach for my coffee. So let's think about place numbers. The number 742. What that actually means is the 2 is in the digits column, right? So that's 2 times 1. The 4 is in the tens column.
Which is...
4 times 10, because it's not a 4, it stands for 40. Sorry.
I was going to say that.
Okay, you say that. And then the 7 is in the
Hundreds column.
Hundreds
so
column.
7 times 100.
7 times 100. So that becomes 742.
You might have also seen this in math class. It's known as expanded form.
The expanded form, yeah.
So
So
700 plus 40 plus 2.
yeah, expanded form. And what grade do you think that is? Grade 3?
I'm going to like grade 2.
2? Okay, so about grade 2 stuff. But expanded form, that's these big numbers.
That's basically the idea.
Yeah.
That's basically the idea.
Every column goes up by a power of 10. So you see the power of 10, the 1,
Which is
right? And then 10 to the power of 1 is 10, and then 10 to the power of 2 is 100, right? So you're multiplying it by itself, each column.
Another simpler way of putting it, if it has a 0, you add the 0 onto the number.
Yes.
So if you have 4 and you times it by 10, it's a 4 plus a 0.
Yeah.
Yeah.
40. But that doesn't, see, that's something that doesn't translate well into binary, but we'll carry on. So the decimal system, that's the decimal system. The decimal system is how we count using base 10.
Yes.
10 digits from 0 to 9. Remember when we were labeling the boxes over the last 2 or 3 courses? We started at 0.
Every course.
Every lesson
Every
so
course.
far? Yeah, well, we didn't do it today. I forgot. Okay, but we start from 0. 0 is the first number. It goes till 9.
Because 0 and 1.
Okay, so what other words start with deci or deca? Do you know? And but
Stop scaring me!
and put them in the comments down below. Any words that start with deca or deca?
I have 2 off the top of my head.
Okay, name one.
Decimeter and decameter.
Decimeter and decameter. So a decimeter is
10 centimeters.
10
And
centimeters.
decameter.
Decameter! Irene!
A decameter?
A decorator.
A decameter is 10 meters.
10 meters.
I can't
Okay.
talk. I can't talk anymore.
Any other? What about the Olympics? Is there an Olympic event that has 10?
Curling?
Curling?
Is there Olympic curling?
the decathlon. The decathlon? I don't know. There's like shot put and.
I'm confused. I like curling better.
Okay. Well, curling doesn't have the powers of 10. So anyway, I guess that question was a bomb. All right. So now we're going to the binary system. That's the decimal system. So, what words do you know that start with bi? Like
Binary.
binary. Okay, other than binary.
Oh.
It has 2 wheels.
Bicycle.
Bicycle.
Bilusions?
Bilution?
Yeah, like illusions of.
Two things.
Yes.
A double illusion is a bilution.
Yes.
No. Maybe. I don't know.
It might be a thing. It might
Yeah.
not.
I know computers. I don't know magic. Other than hands.
Decimalt.
A decimalt? A decimultimeter? Is that the short for that? A decimal?
Oh, what's the one? A dodecahedron. I forgot.
Dodecahedron. That's a do, 2, deca, 10, so 12.
Dodecahedron.
What about a biathlon, where you shoot and ski? Biathlon? Anyway,
I've heard of this.
it's a bi means 2. That's the point of that question.
Okay.
Okay. So the binary system is how we count using base 2. And there are 2 digits, 0 to 1. So back here, we had 10 digits from, sorry, I'm never going to get that, 10 digits from 0 to 9.
Just point.
Here
just
we have
point the opposite of me.
2 digits, 0 and 1. That's it. Okay?
Ow.
So let's think of this number. Don't worry about what it is. It's 1011.
It's
Okay?
simple. It's 2 numbers.
Okay? No, it's 1 number. Okay? So
Oh, yeah.
this number, this placeholder,
Digit.
right?
This
Think
digit.
this digit, yep,
Digit.
is 1 times 1. So rather than the powers of 10, it's going to be the powers of 2.
Do I write this down?
You can if you want. This one
Ow!
is
Hit my elbow.
1 times 2. This one is 0 times 4. This one is 1 times 8. Okay? So if we add up 1 plus 2 plus 8, what do you get?
You get 11.
11. So this number, 1011, is the binary representation of the number 11.
Also.
Okay, so do you see just before you begin, do you see the similarity between the placeholder values of the base 10 and the placeholder values of the base 2?
I erased it. Oh, I'm using the wrong color. Pardon?
Do you see how there's placeholder values?
Yes.
And then base 10 it goes up by a power of 10, and here it goes up just by the power of 2?
Yes.
Okay, so good.
Also, quickly,
Also,
you noticed on my beautiful drawing on the whiteboard.
here, wait, let me make it awesome. Camera and mini screen. There you go. Yay!
You noticed every time you multiply by it, goes up by our powers of 2.
Yeah.
Can't forget the powers of 2. It's important. That's how important it is. It's important.
Yeah.
Okay.
Okay. Hi, buddy. Come in, love. Come and join some math. Okay. So let's go back to our beep and beep. Oh wait. Beep. There we go. Every column goes up by a power of 2.
Yes, it does.
Good. So now going back to our
13.
brain teaser. Hi.
Hi.
Okay, so going back to our brain teaser. Okay, so we said to make the number 13, we used 8, 4, and 1.
Yes.
So now, if we convert it into binary, the number 13, look at the screen.
Okay.
0, 1, 1, 0, 1. Huh.
I
Isn't
wonder
that
why.
cool?
I wonder why.
No, but that's all it is. So when you think about binary, just think about how can I make this number using only the
Base 2.
using only the powers of 2.
Base 2.
That's all it is, and that's it. So now let's count.
Let's count.
Okay, so now this is. I hope this slide will work for us, but here we go. So we're going to count to about 12. I don't know, however many fits on the slide. We're going to start counting to 12, and I'll show you what the numbers are. So there's 1.
1.
Right? So 1 doesn't change. 2.
So there's whoa! What is
2
happening?
is
2.
1 to the 1
1 and
times
0.
2 and 0 times 1.
So there's Another way of putting it, there's 1, 2, and 0 ones.
Yeah.
1, 2, 0 1.
Exactly. Here's the number 3.
There's 1, 2, and 1, 1.
Yeah,
Because-
2 plus 1 is 3.
Yeah.
Okay.
Yeah.
The number 4.
It's 1, 0, 0. 1, 4,
And that's it.
nothing else.
Yeah. The number. So what do you think the number 5 would be if you had to guess now?
I would guess 1, 0, 1.
Yeah, because it's 4 plus 1 is 5.
Yeah.
Right?
You're not allowed to subtract, so you're
Easy.
not allowed to do that.
And a good rule to know is like every odd binary number will have a 1 at the last character, right? Because it's odd, because it always has that 1 to add.
Yes.
All right. So 6. What are we at? 5, 6. Right?
1, 1, 0.
Yeah. 2 plus 4. 7 is 4 plus 2 plus 1.
1, 1, 1. Yeah, Moko.
Okay,
Sorry,
Moko.
Yeah, Moko.
So then 8?
8 is 1, 0, 0, 0.
So it's 1.
1,000.
No.
1,
It's
0,
8.
0.
Exactly. It's 8. Yeah, it's not 1,000. 1,000 is 1,000.
Yeah.
Okay. 9,
10.
10, 11, 12. Okay. So here's
wow.
some.
Oh, wow.
Yeah, this. See, I initially had this slide and I didn't really like it, so that's why I went to this one. But I kept the slide in there. It might be a lot too information for the little ones.
Ah, Moki.
You can let them out, please. Okay. So now we're gonna do what's this number?
Wait, whoa.
Okay, let Moki out. Yeah.
Can we get
And
the
we're gonna
bag
do an easy one for the little kids first, and then we're gonna do a little bit of a harder one
for the mean?
for the older kids.
Ainsley's and the.
Oh.
Oh, what?
Mackenzie's
dog-
dog is with her too.
Yay,
Copper is not
doggos.
on.
Doggos.
Yeah, doggos.
Doggos.
Okay, so what do you think this number? So what we do is it's easy. It's a good. I still do this today. I put my powers of 2 down underneath it, and then it becomes fairly obvious on what it
I
is.
should do that.
Yeah, so you do that.
I'm just gonna do that really quick because I didn't see this lesson before it was done. I only saw a couple of slides. So this is learning for me too.
My doggo is Bauer. It's a good dog name.
Doggo. Wonderful. I am ready.
Okay, so 101.
It's 5.
5,
It's 5.
right? 4 plus 1 equals 5.
Yes.
Okay, so now this one's a little bit harder. So it's okay if the little ones don't get it. 1, 0, 1, 1. I don't even know what it is. 1, 1.
What? Whoa! Why is it so? 1 0 1 1 0 0 1 1.
Yeah, 1, 0, 1, 1, 0, 0, 1, 1.
Oh my gosh! Hold on. Let me do some math here. 3, 19.
Okay, so
1. Hold on. Okay, 1. That's 1. 179.
boom! Yeah, yeah.
Takes a while to do math, but we did it. I did it.
Yeah, you did great. You did amazing. He is so fluffy, and we have to groom him.
That's
To the Libbies that asked you, they said he is so fluffy, and yes, we have to groom him a lot because he is so fluffy.
we had to shave his belly because
And we had to
he
shave his
was
belly
mad.
because he was getting matted.
It was not fun.
Yeah.
It was not fun for the bear.
So
So,
next up,
what's this number?
that's this number. We're gonna practice again.
My goodness.
So 1, 1. Oh, I know what I did here. Okay.
Jeez, stop yelling! You're scaring me!
You're saying that I'm more scarier than binary numbers?
Yes.
Yeah. So 1, 1, 1, 1. What's that one?
Hold on. Give me a minute.
1, 1, 1, 1.
15.
15.
Okay.
Okay. Yeah. 8 plus 4 plus 1 plus 8 plus 4 plus 2 plus 1 equals 15.
Another way of putting it easily to do F13. Oh, whoops.
1, 1, 1, 1, 1, 1, 1, 1. What do you think that one
This is
is?
gonna take me a while. Hold on.
Okay. Well, this one it's kind of a little trick here. So if it is all 1, 1, 1, 1, 1, 1, so let's say you have 9, 9, 9, 9, 9.
909.
Okay, no, just say you have 999, 999. Okay?
Wait,
We'll,
let's get the whiteboard. Can I write it down?
yeah. So let's say you have 999. Okay, so add 1. Plus 1. What does it become?
It becomes 0, 0, 0, 1.
Good. So now there's, this way? Yeah, there we go. So now there's 4 digits, right? So we add another column. Okay, it carries over, right? Well, same thing when you have 1, 1, 1, 1, 1s in base 2, right? This becomes 200 and, this becomes 255. And what's the next power of 2 after 128?
256.
256. There's a pattern there, right? So if it's 1, 1, 1, 1, it is, the next one is 16, right? You see 1, 1, 1, 1, the top one.
Oh,
Right,
top
it's 15, right? And so that would be 255.
Oh my goodness.
So it's
a
1.
pattern.
Yeah, it's a pattern. So when you have 1, 1, 1, the next one would be the next base of 2 that you carry over to. Okay? So 2 new words. We have binary digit and we have byte. Sorry. We have 2 new words. Bit, right?
Bit.
Is a binary digit.
Like it's not like I bit my sister.
No.
It's like it's a binary digit.
Yeah, bit. But yeah, I bit my sister. I only took a little bit. that's a math joke, right? When you take one number away.
I have bite.
Okay, and what's a byte?
You did not bite your sister. No, it's 8 bits.
8 bits.
It's 8 bits.
It's a group of 8 of them. And
Also, don't bite your siblings. Don't bite your siblings.
here, this is a computer science joke, but it's actually true and it's actually a real term. What do you think 4 bits are called? If 8 bits is a byte. Good job, Dana got the answer of 255.
Yay.
Maria got the answer of 255. Dana and Maria.
It's 4.
What's half of a byte? What would you call half of a byte in real? An eat?
Eat.
It's a nibble. A nibble. No, I'm kidding. 4 bits is called a nibble.
Oh my gosh, it's all biting. It's all like eating and biting. Why?
Because it's just what they did. They thought they were funny at the time. Okay.
It's not. It's confusing.
So my sister bites me. What?
No. Don't bite your siblings.
Don't bite siblings. And actually, last class, when Gordon B were here, they were talking about when I was 6.
Oh, okay.
Oh. Which is not a power of 2.
Good point.
Yeah. Okay. So what have we learned? Let's go back and actually do some Minecraft.
Whoa.
Let's go back and do some Minecraft. Okay, so we can show how it actually works
Let me move
in
my
real life. Yeah, and we'll move the keyboard over to you.
Hey.
And that over there, and we'll press play. Good enough here. Move your water.
No water. I need to be hydrated. Whoa.
Yeah, but I don't want my keyboard to be hydrated.
Minecraft. Oh. Mojang. They're bees.
Single player. Yeah, there are bees now.
I didn't know that they were.
I didn't know that there were bees. I haven't played Minecraft in a while, but
Nerd
there are bees now in
life.
Minecraft apparently, kids.
Nerd life. They also can sting you when you get poisoned, so be careful.
Okay, so here we have
Ta-da!
let's wait a second till it. Okay, so now their CPU's at 8%, so now it shouldn't be. So let's go here. What you're going to do is you're going to carry on and make our little counter here. Okay, so go up.
Excuse me, you're in the way. You're in the way, Mr. Creeper.
Okay, so go to the first one.
Oh, whoops.
Go to the one all the way to the left. Okay, so here we have just little logic gates, or just little levers that turn on and off numbers.
See?
And then we just use these numbers to make an abstraction of
You're in the way again.
numbers. So can you finish off building our little thing?
Yes.
So now Ainsley's going to continue building our little circuit here. And nice. And if you guys have any questions, and you are 8, which is a power of 2. Yay! All right. So here we go. So Ainsley,
Yes.
can you make the number, I don't know, who wants to make a number? Let's make the number, we'll start off with an easy one. 5. We'll do 6. Can you make the number 6?
Yeah. Aw. Hold on.
Yeah, weather clear. Nice. There's a duration?
Yeah.
Whoa.
Yeah.
That's awesome.
Yeah. So what number are we making?
6. Did I say 6? All right. So 2 plus 4 plus 2 is 6. So that's the number 6
Should I change it to night?
in circuits.
Should I change it?
No, night was too dark.
Oh.
Yeah, when I reviewed it, night was too dark.
Ah.
Good. So let's make the number 17. Try the number 17, a nice prime number.
Well, let me just
Okay.
have a fresh slate.
So it's an odd number.
So we're going to need Mr. 1.
We're going to need Mr. 1. 17. And is there a power to the... There you go. So the binary representation... Now you want to go a little bit closer? A little bit closer? A little bit closer? A little bit closer? A little... Stop! Back. Right there. Okay. So the binary representation from left to right is 0, 0, 0, 1, 0, 0, 0, 1, which you can see right there in the lights. Those light up.
Oh, 0, 0, 0, 1, 0, 0.
Oh.
Oh! Let me just turn these off.
Okay. Now, do you want to click some random ones and see if we can figure out what number it is?
Sure.
Okay.
So I don't know what numbers these are. 'cause
Yeah,
I'm not
cool.
looking.
And then I can figure it out and I can take it through the kids. Take the kids through it.
Okay.
So, can you pass me the whiteboard, please?
Whiteboard, okay, whiteboard.
And maybe the blue marker. Oh, boop, boop. You got me right in the face, as it were. Okay.
Let's see what number.
So you have.
Oh wow.
Let's go. Okay, that's. I still see it all. Let's zoom in a little bit. So we
A
have.
little bit. A little bit.
So the first one is 128. So we have a 128 that's lit. Then we have a 0, 0, 1, 1, 1, 0, 1.
Beautiful. That's just camera mini.
Yeah, I know. I gotta.
You need to click. No. Whoa.
I gotta do that, and then I gotta do that.
What the? What?
Yeah, you gotta Alt Tab.
I am confused.
Yeah. So we have a. That's the number it looks like. All right. So the leftmost is lit, and then 2 not lit, and then 1, 1, 1, and then
0, 1.
not lit, and then lit. Right?
Oh,
As we
yes,
can
we
see.
are in creator mode.
We are definitely in creative mode.
How come the creeper was so close? I don't know. It just came up and.
That's the Lester boys. Hi, Lester boys. Yeah, the creeper was so close because it was in creative mode, and the Libby's already answered that for you. That's amazing. See, the chat is helping people out. Yeah, kids are helping out kids. This is exactly what
Where? What?
Schooling from Home is about.
How come the creeper was so close? Creative. Oh!
You tracking? Are you tracking?
I'm tracking. I'm tracking. I'm tracking.
Okay, so let's figure this one out. We have the ones.
Face.
Did I hit you in the face? Sorry.
Almost did.
Okay, so we'll change colors here because that's how we do.
Use the other blue one.
The other blue darker.
Yeah.
Nice, it is. So we have this number.
You're welcome.
So it's 1. And then, well, first what we'll do is we'll write out our powers of 2 beyond. So 1, 2, 4, 8, 16, 32, 64, 128. All right? There we go. And I know I'm messy. I'm very messy with my writing.
Messy.
Okay, but we have 128 plus 16 plus 8 plus 4
Plus 1.
plus 1.
No problem.
All
I'm
right?
reading the comments as they come out.
128 plus 8 plus 4 plus 1.
Yep.
So, how to do this? Well, we can do 5 plus 8 is 13. plus 16 is 29, right? Plus 128, which is 7. Carry the 1, 5, and 1. 157? 157 on an undercover cop, right? It's 187.
Do you play Roblox? My handwriting is worse.
Do we play Roblox? Well, you guys do. I
play
don't.
Roblox.
Yeah. So now we're
but
gonna.
we're using Minecraft because I don't know if there are any Roblox games that do that.
Yeah, I don't know if there are circuits. If there are circuits in Roblox, I could figure out how to do that. But the girls, you guys also play with the Chessels, and you play with a lot of other families on the Roblox, right?
A lot of dance people.
Okay.
Because we do dance.
The dance.
A lot of dance kids.
The dance. Okay,
Also,
so
like 4 versions of Waverly.
do you want to do another circuit,
Make one?
or does
Sure.
anyone have another number that they want to?
Gosh, it's so dark.
And it's so dark, I know. So let's do it today.
T.
What time?
Set.
Set.
Day.
Day.
Space. 10000. What?
That's probably too big.
Oh, maybe just 1000.
There we go.
I set the time to 1000. I was right.
It's okay. So let's do this one, and this one. So
Oh, let me do the math.
yeah. So you do it. Yeah.
Let me do the math. I do it differently.
And actually, we can.
I'm just gonna erase the whole thing.
So,
Hold
now that we're
on,
flying
let's
up
go
here.
on. Excuse me. So, 0, 0, 1, 0, 1.
So it's 0, 0, 1, 0, 1, 0, 1, 0.
0, 0, 1, 0, 1, 0, 1, 0. Okay then, which is 1, 2, 4, 8, 16, 32. Cause I have 32.
64.
64 and 128. I'm guessing.
Yep. Okay, so let's see what Ainsley just did here.
They're in the same color, so I'm sorry if it's hard to see. Yeah.
Okay, good. And look, there's a Roblox game that's going to be set up. So that's what Ainsley just did. So now, which ones have ones on them? So we have a
So
2.
we ignore. I'm just gonna cross them.
Yeah, sure.
Ignore. So we only have 32, 8, and 2.
Yep. So 32 plus 8 plus 2. Sorry.
Excuse me.
Sorry.
Excuse me.
Dad just wants to do the stuff.
42.
42. The answer to life, the universe, and everything. You guys should read Hitchhiker's Guide to the Galaxy. It's a really good series of books, and they're hilarious.
I'm reading a good book.
So that's what Ainsley did to figure it out.
Well, it's also because certain math problems are engraved in my mind, like 10 plus another 10 is that plus 1.
Okay. So that is that. Let's get out of Minecraft now.
We
Save
don't
quick title.
need you Minecraft anymore.
Okay. And there we go. We're back.
Bye.
Bye. So what have we learned today? What did we learn?
We have learned that our normal counting base is 10 digits from 0 to 9. Each column is a new power of 10. 728. Is it 724?
728.
It was 724, wasn't
It
it?
was 749. I just picked some random numbers.
Okay. 728 is 728 is 7 times 100. 2 plus 2 times 10 plus 8 times 1. Bed mass.
Yeah.
Bed mass.
Okay.
Binary counting is base 2, digits from 0 to 1. Each column is a power of 2. 1011 is 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1, which is also bed mass. Again,
Yeah.
bed mass.
Okay. So homework.
Oh, yeah.
What's our homework joke, Ainsley?
Cabbage.
Oh, no, that was our homework from Charles Babbage.
Cabbage.
No. It's all work is homework during a pandemic.
You sound like a horse. You got spit on me. Drink it.
Oh, we can't do that
Yeah,
anymore.
I don't want.
Oh, that's a test slide.
Whoa,
Oh,
whoa, 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 whoa.
so I didn't do any homework. So what your homework is if you want to play some Minecraft and make an 8-bit little thing to practice an 8-bit little
Oh, binary.
redstone circuit that you can turn on and turn off to practice your binary numbers, that would be ideal. If you can't do that, then you can do it in Legos just by using different colors to simulate on and off. And it's basically just lining up 8 little bars. Can I do 4 and 1087? Do you mean like as numbers, Waverly? Like do you want to go through how to do the number 4?
Begin writing. Done.
No.
It's already a number. It's already a
You
number.
can do it on Roblox. Okay, so I think the question is, can we do the number 4? Just screen? No, camera and mini screen. Okay, here we go.
Hey!
So, can you just
I'm not moving.
scooch it a little bit? There we go. Okay. So the number 4. We'll write our
I'm coming, Doggo.
powers of 2 right here.
I'm getting a little.
Okay, so we have 1, 2, 4, 8. So to write the number 4, we will find out what numbers are there. So it's a 0, a 0, a 1, and a 0. So that 1, 0, 0 is the number 4. Yeah.
What are you doing?
I'm
Stop!
ready.
No!
Okay, then I'll hold it nice and steady. So the number 4 is
0, 1, 0, 0.
yeah.
I'm guessing. Is it 1? No, no,
Yeah.
no. 0, 1, 0, 0.
Okay. So, and now there's a lot of talk about Roblox in the old chat there, which is awesome.
Roblox.
So that's today's lesson, guys. If anyone has any questions, we'll be online for a minute or two, and we'll save the chat so you guys can get all your account information so you guys can play Roblox together.
Yeah, because it's good to have friends in it.
Good to have friends, and yeah.
Especially socializing, because then you don't want to go stir crazy.
Yeah, we don't want to go stir crazy. You are welcome so much, Liddies. Other than that, what else is going on?
I'm wearing a shawl today.
You're wearing a shawl today, a Totoro shawl.
Yeah, let's put up the shawl.
Totoro.
Oh, wrong ear.
And my dad will call you later. Awesome.
Has anybody watched the Totoro movie? I need to know this because I've only met one other person who's seen this movie. So I need.
Can you dab, elbow cough, elbow cough? You want to do bang 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 bang? Want to do a dance?
5, 6, 7, 8.
Bang, bang.
Oh
That's
no!
it? Okay.
The Toronto's.
Well, we'll log off. Love you lots. Everyone, you guys are still loved. Everything is great, and we're going to carry on. Are you on tomorrow? No, our usual schedule now is going to be Monday, Wednesday, Friday at 1:30 p.m.
Yes, we do.
We do get your daily TikTok, and it's hilarious. Yeah, Monday, Wednesday, Friday, 1:30 p.m. Collingwood, Ontario time. Until I have to work one day. Well, I still work. I work, but just I'm given this time to do this. So that's it.
Bye.
Bye.
Adios.